So assignment related to organic chemistry, the introduction to organic chemistry. The doubts were question 11, 12, and 13. So the correct name for this. So how to identify, like how to write a correct name, we have to select the longest carbon chain. So we have to select the longest carbon chain. So if I say this is 1, 2, 3, 4, 5, 6, 7. So this will make 7. Right? Because and we have to include a double bond as well. The correct IUPAC name for this one. Like if I overall make the structure, it is like starting from right hand side. So this is CH3. Then next to that is C is there. Then there's a double bond. And this is having CH2, CH3. And then we have C. And this is having CH because it's CH and then CH and then CH2 and CH3. Like with this carbon, there's a CH. It should be CH3, not CH only, because like 3, I think it's missing, but it should be CH3. Otherwise, it won't be a correct structure. Then we'll have CH. And this CH is surrounded by CH3 and 2 is CH3. So CH3 and CH3. Now what we have to do, we have to select the longest carbon chain. So when we select the longest carbon chain, if I start from here 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, and I have to include the double bond as well. So this looks the longest, like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So 6 give us the longest carbon chain. Then after selecting the longest carbon chain, numbering should start from the nearest double bond. So where we have the closest double bonds, if I count from here, this will be 1, 2, and 3. Third carbon will have a double bond. If I count from here, 1, 2, and 3. So both ways, even if I start numbering from the top or from the left, I'll get the same position for double bond. Then we have to check give the priority to the branches. Like this is CH3, CH3, and CH3. So where we have a closer branches, like if I count from the top, the branch is like 1, 2, and 3. The branch is coming at third. But if I count from here 1, 2, and 3, the branch is coming at 2. So means I should start from the left hand side. So 1, 2, 3, 4, 5, and 6. So which position we have a branch? We have a branch at second position. We have a branch at third position. And we have a branch because 1, 2, 3, and this is the fourth one. So we have the branch at the fourth position. So 1, 2, 1 is not there, 2, 3, and 4. And 3 branches are there. So for 3 branches, identical branches, try. And each branch contains 1 carbon. So it is meth and YL, methyl. And they have, like there are 6 carbon atoms, 1, 2, 3, 4, 5, 6. So it will be hex. And the position of a double bond, the double bond with the third carbon, that's why it is hex 3E. Is it clear, this one?
Yes, sir. But in option, there is not given trimethyl. It's given triethyl.
No, it's methyl. M. T-R-I-M.
Okay, fine.
Trimethyl. So you have to just make a structure like this, structural for change the structural formula to display one and then identify. Which one of the following is not a structural isomer of compound M? So structural isomers, they should have same like type of a compound, but they have a different structure. So you can count the number of the carbon atoms. Here this is having 1, 2, 3, 4. Like 1, 2, 3, 4 carbons are there, so C4. How many hydrogens are there? 1, 3, 4, 5, 6. So 6. And how many oxygen are there? 2 oxygen. So C4, H6 and O2. What about this one? 1, 2, 3, 4. So C4, H6, O2. What about this one? 1, 2, 3, 4. So C4, H6 and O2. What about this one? 1, 2, 3, 4. C4 and 3, 4, 5 and 6. They all will have the same molecular formula, but we have to find so like which of the following is not structural isomer. So when you check for this one, 1, 2, 3, 4, C4 are there, and H 3, 4, 5, and 6, and O2. So they all have the same molecular formula, but how we can identify? So this compound is what, like, see about this one. This is carboxylic acid. Like there is a group of C double bonded with O and O. When you check for this one, and so C double bonded with O is there. When you check this group, C double bonded with O and N, because this COO means C double bonded with O and O is there as well. When you check this compound, what it contains, and what about this one, the aldehyde that is having C double bonded with O and H. But what about this one? There is no C double bonded with O. Like example, there is a C double bonded with O in structure A. There is a C double bonded with O in structure B. There is a C double bonded with O in structure C. But there is no C double bonded with O in structure, sorry, there is no C double bonded with O in structure C. But there are C double bonded with O in structure A, structure B, and structure D. That's why structure C is not the structural isomer. Like it's not having the same like different structure. It is actually a totally entirely different groups are there. Is it clear? Question 12.
Yes,
Right.
sir.
So you have to check the structure. And the last one, the number of structural isomers of C3, H2 and Cl6. So 3 carbon atoms are there. 6 chlorine are there. And 2 hydrogen. So how many different ways we can arrange this? So for the same 3 carbon atoms, so if I put Cl, all Cl first, like first this will have Cl, all 3 Cl with this one, the remaining 2 Cl with this one Cl with this one, and hydrogen. This is the one structure. Like 2 hydrogens are there, 6 Cl groups are there, and then if I move to other side, like if I move, keep it same. So 3 carbon atoms, Because for carbon, for 3 carbon atom, we cannot make a branch. So it will always be a straight chain. Now, this will have 3. If the last one is also having 3, then this will have 2 hydrogen. And if I make this will have 3 and this will have 2 and the last one will have 2, that does not make difference. Why it does not make difference? Because it's the same thing. Like if I draw the structure with this one, that this is having 3 chlorine atoms, this will have 2 chlorine atoms, and this will have only 1 chlorine atom and then 2 hydrogen. This does not make difference. This is actually same. I like, so what I can do, now if I made 2, this Cl is there, this Cl, this Cl, this Cl, this Cl, and this Cl, and then H and there's H. So like the 2 ends of a carbon, or maybe like hydrogens are there with 1 and 2, because the possibility both hydrogen are attached to 1 carbon, first carbon, or both hydrogen might be attached to second carbon, or 1 hydrogen with the first and the last carbon and 1 hydrogen with first and the second carbon, and then we'll have Cl. So these are the possible structures. No other possible, like if you try to make any other combination, you will not be able to. So this shows like how many possible isomers, structural isomers are there. That is 4, so that's why C will be the right answer. So you have to draw the structure. Is it clear?
Yes, sir. Yeah.
Yes.
So these are the doubts. Question 11, 12, and 13 from this topic.